Hello, everybody. This is session 4, and today we'll talk about analyzing quantitative data.
Last session, we talked about qualitative research. If you remember, we said that there are four main types of qualitative research. We talked about ethnography, case study, action research, and grounded theory. Today, we will try to introduce some basic concepts related to statistical analysis, which are of importance in applied linguistics research. In fact, mastering statistics is essential for all researchers in all fields of study because it enables them to both do research and also become an informed and discerning consumer of the research carried out by others. In fact, it is observed that most MA and PhD students find the task of mastering statistics quite intimidating. And in reality, it is quite intimidating. Remember that given the nature of this MA course, we cannot provide everything, all of the details about the statistics. Therefore, the slides given here are not all exclusive and sufficient for a complete understanding of everything related to statistical analysis. There is a saying that analysis is the act of giving meaning to data. Statistical procedures help us to make inferences and predictions concerning human or non-human behaviors. In fact, statistics play important roles in our society. The goal of statistics, we can say, is to use data in order to infer facts, in order to make decisions, and also to make predictions about the world. Therefore, we are going to infer some facts and then make decisions and afterwards make predictions about the world using statistics. Statistics is the study of collecting, organizing, describing, analyzing, and interpreting the data. Therefore, we can say that statistics has three main functions, and they are description, measurement of relationships, and also generalization. It has applications to virtually all areas of our lives, from business, health, nutrition, politics, and also education. So, as you can see, statistics play a very important role in our society. Now, the question is this: why statistics are important? In fact, statistics are important because they assist the researcher by setting up procedures for assembling data, recording it properly, and also analyzing it properly. In fact, statistics generalize to a broader population from a representative sample. In fact, they help us to generalize what we find about a sample to a larger population, to a broader population. Statistics are important because they determine when generalizations are sound, when generalizations are possible, and also how far it is permissible to interpret them. Statistics are important because they determine whether there is any relationship between two or more factors which are present in a situation. And if there is, how large the relationship is. They are important because they describe and evaluate experiences and phenomena in an objective manner in comparison to subjective manner. Here, when you are dealing with the statistics, everything is related to numbers and is done by softwares like SPSS. Therefore, your own taste, your own attitude cannot be included in the results. This is why we say it is objective, not subjective. In fact, in statistics, we extract from a mass of data the truth. This is perhaps the most fruitful realm of statistics, and it has made a great contribution both to our knowledge and to our power to manipulate the forces in our environment. Statistics can be categorized as two major types: descriptive statistics and inferential statistics. Descriptive and inferential statistics play a significant role in quantitative research traditions to determine the relationships or differences among variables and also the likelihood that the results are due to the manipulation, not chance. The first issue we deal with has to do with description and data display. In fact, descriptive statistics can help to provide a simple summary or overview of the data, thus allowing researchers to gain a better overall understanding of the data set. We can say that descriptive statistics are of three types: measures of frequency, measures of central tendency, and measures of variability. In the following slides, we will talk about these three measures one by one. What is descriptive statistics? Descriptive statistics enable researchers to organize, summarize, and describe observations. They simplify our lives by organizing and summarizing data. In fact, the general function of statistics is to summarize the large number of scores which have been obtained from a sample, and then to see if the scores obtained are generalizable to a larger population. This is the function of descriptive statistics. More specifically, descriptive statistics uses a few numbers to grasp the meaning of a much larger collection of observations on many different cases. That is generalization. In your own study, you use descriptive statistics and then you analyze few numbers that are based on your own sample. And afterwards, you want to generalize it to the larger population on many different cases. In the realm of applied linguistics, computing descriptive statistics is merely the beginning of a more complex process in which more advanced statistical methods are utilized to make generalizations about cases that have not been measured directly. Therefore, first we have descriptive statistics, then we will have inferential statistics, which is more complex. As I said before, there are three different types of descriptive statistics: measures of frequency, central tendency, and variability. Measures of frequency are simple, relative, and cumulative frequency. Measures of central tendency include mean, median, and mode. Measures of variability include variance, standard deviation, and range. Because raw data are not particularly revealing, they must be organized and described in order to be informative. Suppose that you have done your research And now you have a data sheet in front of you full of numbers from the tests, from the questionnaires you have administered. Now you have maybe more, 2, 3 sheets of paper full of numbers. Are they revealing? No, they are raw data. You need to use descriptive statistics in order to have a kind of summary. And then based on descriptive statistics, you can describe your data. The first type of descriptive statistic is measure of frequency. Measures of frequency are used to indicate how often a particular behavior or phenomena is occurred. For example, in second language studies, researchers might be interested in telling how often learners make errors, or how often they engage in a particular classroom behavior. One of the most common ways to present frequencies is in table format, as you can see in the example. This is a sample frequency table extracted from Storch and Tapper, 1996. I got it from their own paper. They provided the frequencies of different types of annotations that second language writers made on their own texts. As you can see here, the content of a student's annotations are related to prepositions, verb tense, articles, verb forms, etc. In front of these, you can see the next column, number. For example, look at the second row, verb tense, and the number is 17. This means that 17 annotations were made by students and they were related to verb tense. Or for example, 6 annotations were made by students about verb forms. In addition to tables, frequencies may also be represented graphically in forms such as histograms, bar graphs, or frequency polygons. In these graphic representations, the categories are typically plotted along the horizontal axis, whereas the frequencies are plotted along the vertical axis. For example, if we were to convert Storch and Tapper's 1996 frequency table into a graphic representation, one possible way would be through the bar graph, as you can see. This is a bar graph and the frequencies are the same ones in the previous slide. Look at the first bar. It is related to the syntactic part. It shows that nearly 120 or 118 comments or annotations were made by students related to the syntactic parts. We can also show the frequencies in another form. And you can see, as you can see, with the same data, we have a line graph. And they are the same. Frequencies, as well as measures of central tendency, which we will describe later, are often presented in second language studies, even when they do not relate directly to the research questions. This is because frequency measures provide a kind of summary of the basic characteristics of the data, and they allow reader to understand the nature of the data with minimum space expenditure. Next category in descriptive statistics is measures of central tendency. In fact, measures of central tendency provide information about the central point of a distribution. We have 3 measures of central tendency, namely mode, median, and mean. Mode is the most frequent or common case or value or number in a distribution. For example, if the ESL proficiency test scores recorded for a group of students were 78, 92, 92, 74, 89, and 80, here we can identify the mode. Look at this distribution. Which score or scores are the most frequent ones? Or which score has the highest frequency? As you can see in this distribution, all of the scores happened only once, except two scores. The second one and the third one. We have two 92s. Therefore, here the mode is 92. And as you can see, this measure is convenient. It does not require any kind of calculation. Next measure of central tendency is median. Median is the midpoint or the central value or number in a distribution. Look at this distribution: 1, 2, 4, 6, 8, 9, and 10. Which number is the one in the middle physically? First we have 1, 2, 4, then 6, and then we have 8, 9, and 10. Which score is in the middle? Yes, 6 is in the middle. 3 scores on the right, 3 scores on the left. Or for example, in the previous distribution, which one is the median? Here, as you can see, first thing to do is to rank the scores. Therefore, first we rank the scores. First one is 74, next is 78, then 80, 81, 92, 92. So remember, first we have to rank the scores. Then we find the score in the middle. What are the scores in the middle in this distribution? As you can see here, we have two scores in the middle, 80 and 89. These are the two scores in the middle. When we have two adjacent scores in the middle, we need to calculate the average of the two. What is the average of 80 and 89? We add 80 plus 89, then divide it by 2. So the average here is 84.5. Therefore, the median of this distribution is 84.5. And the most common measure of central tendency is the mean, or the arithmetic average. The technical term for what people know as the average of a set of values is the mean, or the average. All of you, I think, can calculate the average or the mean of a set of scores. For example, in our distribution about the ESL proficiency test, we have 74, 78, 80, 89, 92, and 92. You add them all up and then divide them by the number, which is 6. Then you can come to the mean, which equals 84.2. The mean may be represented visually through the use of graphics, including a bar graph. As you can see here, we have a bar graph in which you can see the mean scores for 3 groups: QA, question group, input group, IP, and task group, TB. And again, the means are shown by 3 colors: pre-test, post-test, and delayed post-test. That is, in each of these 3 groups, we have 3 tests: pretest, posttest, and delayed posttest, and you can simply see that, for example, in the first group, the question group, post-test and delayed post-test, they have the same mean, and the mean score of the pretest is smaller than the mean score of the post-test and delayed post-test. Or alternatively, means may be shown through the use of a line graph. As you can see in the example, in this study, the author compared patterns of consonant to consonant timing at word boundaries in Russian and English to investigate the roles of transfer and the emergence of linguistic universals in second language acquisition. Again, you can see that here by patterns, we have English speakers and Russian speakers, and the difference is by patterns. As you can see the guide on the right side, the first one is related to English speakers and the second one is related to Russian speakers. And here on the left side we have the means. You can see that, for example, speaking English, at first the mean score for speaking English was nearly 0.8, and then for speaking Russian it becomes 1.1. Look at this table. On the left column we have the teachers, and on the right column we have the salaries for each of these teachers. We have 10 teachers in an institute, and these are the salaries. And by calculating the mean, we may assume that the average salary in the institute is $1,580. A glance at the raw data, however, makes it explicit that the salaries are between $1,000 to $1,200, and in fact, only one teacher gets a high salary. Look at the table, see which teacher gets a high salary. Teacher number 5, $6,000. This high salary affects the mean. This being the reason, we need to be cautious when we interpret the mean. Here, if you couldn't, for example, take a look at the raw data, you would think that the average salary for this institute is nearly $1,500, but excluding this, in fact, teacher who gets $6,000 and we call him the outlier, you understand that the average salary is somewhere between $1,000 to $1,200. We call this teacher number 5, $6,000. We call it an outlier. In fact, outliers are the values or scores that are very different from the remainder of the values or scores in a distribution, and are usually considered to be the high or low extremes. Here, as you can see, among the salaries, 6,000 is considered as the outlier because it is very high. Thus, in order to present a more reliable description about the distribution of the values or scores, we need to find another way. In fact, we need statistics that would be more sensitive to how all values behave in the data set and how they are spread in the distribution. These are referred to as measures of variability or dispersion. Measures of variability indicate the degree to which the scores are dispersed, or the degree to which the scores are different from each other. It is vital to have a firm understanding of this concept if you want to progress to an understanding of inferential statistics. Measures of variability, also referred to as measures of dispersion or measures of spread, include range, standard deviation, and variance. Range is the difference between the highest and lowest score in a data set. Range is in fact the easiest measure of variability. It is the difference between the maximum and minimum value in a distribution. So to calculate the range, you can simply subtract the maximum from the minimum score. Variance is the second measure of variability. It is the sum of the squared deviations of each score from the mean divided by the number of the scores. Standard deviation is similar to variance. Standard deviation is the square root of variance. It tells us how far, on average, any given score is far from the mean. Standard deviation presents an account of how each score is deviated from a standard point, which is the mean in this calculation, in the distribution. It shows how scores or values in a distribution are spread around the mean. By taking into account the distance between each score and the mean and applying this feature in our calculation of the standard deviation, we actually resolve the problem caused by outliers that could lead to exaggerating the range. We use standard deviation, mean, and for example number of students in a table like this. As you can see, in this table we have 3 levels, and it is about English anxiety. We have the mean of English anxiety in the second column, shown by M. For example, in the first level, the mean score for English anxiety test is 74.42. Or for example, the standard deviation for level 1 equals 14.87, and N shows number of students in this group. Prior to talking about inferential statistics, you need to know the meaning of normal distribution. In a symmetrical distribution or a normal distribution, the frequent values are spread around the mean, and we can say with a very high degree of probability that the mean is the most frequent value and outliers or exceptions are less frequent. Thus, the most frequently occurring value or score becomes the norm. So, if we display the distributions using a curve, we get a symmetrical value that is bell-shaped, in which the peak displays the norm, that is the most frequent value, and the tails, right and left extremes, as you can see in the picture, depict the outliers with very high or very low values. Here we can use an example. As can be seen here, in our example we have 500 students. Okay, assume that 500 students performed on a proficiency test and were rated on the scale of 100. With a mean of 65 and a standard deviation of 10, you can simply make some interpretations. So standard deviation is 10, mean is 65, and number of students 500. Now, based on this figure, as you can see on the left side, the bell-shaped figure, we can say that about 68% of the scores, that is approximately 320 out of 500 students, fall within the mean plus or minus one standard deviation, that is 65 plus or minus one standard deviation, which equals 10. Okay, that is to say 320 students received the scores between 55 and 75. How we came to 55 and 75? 65 minus 10 equals 55, 65 plus 10 equals 75. Now look at the two parts in the middle of the bell-shaped figure, two 34.13s. We can say that 320 students received the score between 55 and 75. Next, we can say that about 34% of the students got the score between 65 and 75, and similarly nearly 34% of the scores fall within one standard deviation below the mean, that is between 55 and 65. We can also say that about 95% or 94% of the scores fall within two standard deviation, that is between 45 and 85. 45. How we come to 45? 65 plus 2 standard deviation, that is 65 plus 20, and 65 minus 20. Plus 20 equals 85, minus 20 equals 45. And at the end, we can say that nearly 98% of the scores fall within three standard deviations of the mean, that is 65 plus and minus 30, that is between 35 and 95. As you can see, outliers will constitute about 6% or 5% of the scores. Up to now, we talked about descriptive statistics. If you remember at the beginning, we said that we have two major types of statistics: descriptive statistics and inferential statistics. Now we want to talk about inferential statistics. Inferential statistics help determine how reliably researchers can infer that phenomena observed in a limited group, that is a sample, are likely to occur in the unobserved larger population of concern from which the sample was drawn. That is, how researchers can infer that something which they observe in their sample may happen in the population. They are called inferential statistics, which help you estimate parameters, characteristics of the population, from statistics, characteristics of the samples. This is why we call them inferential statistics, because you use the characteristics of the sample, which is the statistics, in order to generalize them, in order to estimate the parameters, that is the characteristics of the population. Inferential statistics are used to estimate from a sample what is true for a population and whether or not the obtained results are different from chance. Researchers use inferential statistics when they want to make inferences from the particular sample to the population at large. In fact, inferential statistics refer to the use of sample data to reach some conclusions, that is, make some inferences about the characteristics of the population. Although researchers are sometimes interested in simply describing the characteristics of the sample, for the most part, we are much more concerned with what our sample tells us about the population from which the sample was drawn. Therefore, for us, we can say that inferential statistics are, in fact, more important than descriptive statistics, because at the end we want to infer things, we want to reach some conclusions about the population, not just about the sample. First, in passing, it should be said that in statistics, a distinction is made among univariate, bivariate, and multivariate analysis. The term univariate statistics refers to analysis in which there is a single dependent variable. There may be, however, more than one independent variable. By using statistics, we actually try to use numbers to describe one individual variable. This is why we also refer to this as univariate statistics. Next is bivariate statistics. Bivariate statistics frequently refers to analysis of two variables where neither is an experimental independent variable, and the desire is simply to study the relationship between the variables. For example, the relationship between income and amount of education. Therefore, when we use inferential statistics, we may be interested to explore the relationship between two variables. Because we have two variables, we call it bivariate statistics. And finally, we have multivariate statistics. Multivariate statistics are used when we simultaneously analyze multiple dependent and multiple independent variables. This capability is important in both non-experimental, for example, correlational or survey studies, and experimental research. So further, we may investigate the relationship between several variables or predictors and another variable using multivariate statistics. The major types of statistics used in inferential studies are parametric and nonparametric tests. In parametric tests, when the sample size is large enough and the mean distribution is normal, parametric tests are used. But when the sample size is small and the mean distribution is not normal, we use non-parametric tests. In fact, both techniques assist in determining whether the results obtained from the study are likely to be due to chance or to variables identified in the study. Now, selection of either types, that is parametric or non-parametric tests, depends upon several factors, such as the type of instrument being used to collect the data, the size of the sample selected to participate in the study, the characteristics of the population from which the sample is drawn, and the scales of measuring data, for example, nominal, ordinal, or interval. For example, one criteria for choosing parametric statistical test is that the data should be interval, Or, for example, another criteria for using parametrical tests is that the data should be normally distributed, and the means and standard deviations should appropriately be measured. Or, for example, the assumptions underlying non-parametric tests, although they are minimal, but we have assumptions for non-parametric tests too. For example, non-parametric tests are generally used with frequencies, but for parametric tests we do not use frequencies and things like that. We will talk about these issues in the next session. So all in all, today we talked about goals and importance of statistics in second language research. Then we said that we have two major types of statistics, descriptive and inferential statistics. We started with descriptive statistics, and we said that we have three major types of descriptive statistics, namely measures of frequency, central tendency, and variability. We also discussed things related to normal distribution, and afterwards we gave a discussion about inferential statistics and also parametric and non-parametric statistics. This is the end of session 10. Goodbye.